going to talk about showing information so people can see it. And, I think this is kind of a fundamental part of our whole green room process or collaborative team process, is showing information to people so that they can see what we can see as industrial engineers. So this goes back to keeping it simple. So in order to help people understand system opportunities and create their own ideas, somehow we have to present it to them in a way where they can see it. Because people are very good at seeing patterns, but they're not good at sifting through amounts of data. So you look at a spreadsheet versus looking at a diagram or a pie chart. People are much better at looking at the pie chart versus looking at a bunch of information. So one of the things that we always want to do as a company and as professionals is try to boil things down in a way where they can see it. And there's different types of information, so we're going to start with flow. So if you talk about flow, flow tends to be a huge indicator of waste. So if you think about it, if you have long travel distance, that tends to be bad. And if you have lots of breaks in your flow, where it has to go from one person to another, for example, that tends to be bad. And there are lots of ways that flow can be shown. I'm going to give you some examples here. So this is a real diagram, or just a flow line, where we've got an original. This is the existing layout. This is a work cell at Eaton. The stuff comes in, it goes to this operator, comes over here, and you can kind of see we've used a line here to show the general flow. And then down here on the right, we show a redesigned flow. Again, stuff comes in, it goes through a conveyor, and it comes out over here. So this is an actual example of a redesign. So here's an example of showing people how flow can be changed with, with a change in the layout. We use these quite a bit at Interstate McBee right now. Here's another example of how flow can be shown. This is for Sonopress. And in this case, we wanted to show how a person should walk when they are doing a changeover. So this one operator starts over here. He transfers at this pallet. Then he walks over here and clears this cross stacker. Then he finishes the sticker setup. Then he walks over here and he sets up the spline labeler. Then he removes the overflow and manual load, and then he loads the CDs. And so this is basically his choreography for what he has to do whenever there's a changeover. This other person over here has a similar flow. They start over here. They've got to do some things over here, and then they come back. Again, it's another visual way of showing how a person moves, in this case very specifically when they're doing a changeover. This is an example for Great Lakes Brewing. It's showing the flow of material. So materials come in, they get stored in a cooler. I think actually in this case it comes in, comes over here, goes through this line. This is bottles of beer, basically. They're coming out, and then they're going to this cooler where they're stored, and then they're leaving. And it's another way of visually showing the main route, the routes of ingredients, and the routes of other, which I'm not sure in this case what other represents. Might be like cases or something. Here's another example of a spaghetti flow. This is for frozen specialties, and in their case, we wanted to look at the flow of waste and a number of other things. This particular diagram shows retail cartons and corrugated and how materials flow. They come in. This is where the corrugateds go over to these points, and retail cartons get dropped off in these locations. And we did a series of these for different types of flows. We've also done them similar for Procter & Gamble. So you can show the flow through the warehouse or the facility. In this case, this is a cooler, and at the end of the study, we noted that a lot of materials have to go through this one cooler, and it kind of became a pinch point, and just because of the way the building was originally laid out. Here's another flow diagram. This was for a company called Proto Circuits, and they were doing circuit board manufacturing, and you can see just a tremendous amount of back and forth flow. In this example, there was one piece of equipment here. You see a lot of things have to travel across the facility to go to. And after reviewing this with their team, they came up with the idea of duplicating that piece of equipment and locating that equipment in strategic places. These are all clean room type environments, and everything is moved by cart. So it was a significant reduction in the time for them to get the product through. They had like a 3-week turnaround time, and we were able to cut a week of time out by just looking at this material flow, spaghetti flow diagram, and making some changes to the amount of equipment and where equipment is located. This is a flow intensity diagram. It's got a little bit more information than a spaghetti flow. The thickness and the color of the lines represent the intensity of the flow. And what you would tell if you were showing this to someone, you might say the thicker, longer lines are the ones you really would need to worry about, because it means you have a lot of material flow between those departments, and it's a long distance. Long distance is bad. We did something like this when we did the Gojo facility project that Sarah worked on. This is another type of flow intensity. It's called an aisle congestion diagram, and this is actually being generated by ProPlanner. That one tool that we have, it adds up all the flows within an aisle, and it color codes them and also shows intensity. And the reason you use something like this is to show maybe where you have an aisle area that's going to have a lot of congestion. So you can see where my mouse is here. And the idea is that you want to look at that. Maybe you need to reroute certain products, or maybe you need to make sure that aisleway is wider because you're going to have a lot of congestion in a certain area. There's different ways you can create flow diagrams. One way is if it's material or people flow, you can identify the number of trips, for example, between areas, and then you can create a scale. So this example scale, maybe 5 to 20 trips per day would be a 1, which would be low, and maybe the top one, a 5, would be 81 to 100 trips per day. And you just pick values that you think would make sense, to kind of scale things. And then you give each one of these 1 through 5 a different color and line thickness. And again, the thicker the line, or maybe a red, would represent a high intensity of flow. You can also do it based on desired closeness, and you would use this, for example, in an office environment. There's a rating called the AEIOU rating, and you say you maybe would interview people in different departments and say, well, what department do you need to be close to? Is it absolutely necessary you're next to them, or is it unimportant, or is it maybe even a negative? Like, you wouldn't want to necessarily put the entryway to the building close to the safe where all the money and documents are stored, But maybe you would want to put the accounting department very close to it. Or maybe you wouldn't want to put the paint department right next to the sanding department because of potential contaminants. So again, you give them a AEIOU X. This is an example. This was an actual project that we did for a doctor's office. So you have the office manager, X-ray room. This is these guys were, what is it when you do bones? Anybody?
Orthopedic.
Orthopedic. Yeah, so you can there are 3 different doctors. So we identified the space requirement, and we gave them an AEIOU. So they said Dr. K and A, which happens to be the office manager, they wanted to have those close. That was really important. But then there were some that were used like unimportant, like the receptionist being close to the X-ray room. It wasn't important. And so they created this. And then what we did is we gave them a score, and we put that rating in here, and we added them together, and then it gave us the space relationship diagram. So again, the thicker lines represent areas that need to be close to each other, like the receptionist and the waiting room need to be close. The waiting room and the cast room need to be close because they didn't want people to be walking too far. And so with a diagram like this, it was much easier to sit down with the staff and say, well, how do we lay this out? Each one of these blocks represents a certain amount of square footage. And certain areas that maybe like the break room, they don't really have much of a flow with anything. You could put that anywhere. So that's how you can use this. Again, this is much more visual than giving them this or giving them this. Another way you can show flow is with the use of a value stream map. Here's an example of a value stream map where it shows each of the steps. It shows down here the duration of each step. Up here you have information dealing with, this is the information flow. This is more of the material flow. And the value stream maps, we're not going to get into it, but they have a very specific kind of format that we use. This is a swim lane map, and we actually use this for FFR DSI. And this is the actual process they use for new product launches for the quoting. So stuff comes into the customer, then it goes to CSR, then it goes to the custom order group, and then it goes to engineering, it goes back to the customer group, which goes back to CSR, which goes back to the customer. And what you can see here is a lot of handoffs back and forth. And I put together this drawing and showed it to them and explained how it works. And right away they could see there was a lot of communication between departments. So rather than have engineering talk directly with a customer, there were layers to go back and forth. And so this was used as a basis to identify where we could eliminate handoffs by having more direct communication between departments and the customer, and start to understand, because each one of these handoffs means that there's a chance that that order is going to be sitting there waiting. So the more you can eliminate handoffs and get direct communication between the customer, for example, and different departments, the better. This is another example. This one was for Wyman Products, and we were trying to come up with kind of a concept for how we could streamline the purchasing department. So again, we used something like this, a process flow diagram. This is an example for Gojo. They were introducing a new process, so we created a wall-size map that looked just like this, and we broke it up into time segments. You can see these little lines represent time segments, and we actually showed a picture of how the product's being built up over time. It starts with the bottle gets filled, and we start adding certain things to it. There's like a puck that it goes on until it finally ends up on a pallet, and there's other things on there. So this became a wall-size poster, and then we sat down with the team and kind of facilitated the conversation. Well, where's the big time delays? And each one of these stars represented different opportunities. We actually wrote on it on the wall. Of course, another way that we do a lot of flow, looking at flow, is simulation modeling, whether it's a 2D or 3D model. This is an example of a 3D model. We have ASRS. An ASRS system, automatic storage retrieval system, conveyors with pallets moving, people, forklifts. So that's one kind of, that's looking at flow. Another type of model is spatial modeling to help people visualize how something will look. And that can be anything from a simple 2D AutoCAD drawing to a 3D program. So here's an example of a simple one. This is for Sonopress. We're laying out a line where we've got products coming in. They're getting things put into them. So in this case, you've got, we're making a box, we're inserting a CD, there's inserts, then we close the box, and then we put a sticker on it, and it leaves. And then you can show where people are going to stand. Again, a very simple type process. This is a program that I bought at Best Buy once, like $50, to lay out an office. It shows you an example of a very simple application that looks, certainly helps visualize. I use this when I did my basement. I actually laid out where the pool table and everything would go. And you could do a walkthrough to kind of show spatially how things are going to look. Sometimes it's hard for people to see things using, this 2D kind of drawing. So we go to something a little more sophisticated. This is something that, this is what I call more of a top-end kind of CAD package that shows, again, 3D, where things are going to sit, the lighting, and there certainly are packages out there that do this. We currently don't do anything quite this sophisticated. I think the most sophisticated 3D we do is probably with FlexSim. Another thing that you can use visualization with is to help people focus or prioritize. So trying to help people see where the greatest costs or opportunities are. So examples of these would be like a Pareto chart or a pie chart. Of a Pareto chart, and where the length of the bar represents the amount of production time lost during a shift for a specific cause. So this is, again, an actual project. This was for Sonopress. We looked at downtime, whenever the production line went down, why. And you can see here, this is in terms of time. The top one was break. So you could look at, well, if we want to do staggered breaks, we would eliminate this downtime, about 60 minutes in a shift. We had lunch. We had the spline label setup, manual feed. Again, the point is, if you're trying to worry about the time it takes to load the tray, it's a very small amount of downtime relative to some other things. Kind of helps you quantify that. Here's another way it could be done. We've done these quite a bit. This is for a pharmaceutical company in St. Louis. And we did a pie chart to show them the percentage of time that people spend doing various things. The blue categories are value added, and the white are non-value added. And you can see in this case they actually had a lot of break and lunch. It was beyond what they should have been taking. Early start, late start, cleaning the area, balanced play, which means one person was idle while the other one was working. In this particular project, they wanted to automate this open unfold bag. They were going to spend several $1 million to automate this piece of the pie. And we said, geez, there's a lot of other management issues here. And actually there were some other things that would cost less, like applying adhesive, loading container to pallet, labeling the container was a big one. There was some less expensive automation that would help them address these bigger slices if that's what they wanted to do. They wanted to spend money on some technology. So again, just another visual way of showing it. It's very clear when you see this that the value add is a very small percentage of the time. Some other examples of visual displays can include things like trend charts. Here's a line chart. I just took this off of, just like, what was it, just a stock, basically a stock tracker. This shows, again, trends. You can see it over years or days. This is an example of a setup reduction. Again, this is the same. This happened to be for Sonopress, I believe. And we show the current method where everything is done in sequence, and it takes 60 minutes. These are in minutes. And on the right-hand side is a revised method with 2 people where they're working together, and we got it down to 30 minutes. And so you can start to show people in blocks what people are going to be doing throughout a changeover. We've done more sophisticated ones than this with like Gojo, where they may have a staff of 10 people, and we basically start the clock during a changeover, and we show what each person is doing throughout that changeover. We've done these for Pilkington Glass, where we show what one person is doing while they're loading. One person's in the truck loading it. What is the other person doing? And it becomes a visual way of showing how they balance out their workload. Another simple type of visual system is a simple line chart or a bar chart. This one is an example for some simulation experiments where we can show if you add tanks, how does that affect your throughput? And then again, you can start to see, like going from 6 to 7, there's a huge jump in throughput, and then it starts, in this case, to level out. So you can see where your break point is, where you're starting to level out, and you're maybe not getting the same return on investment. This is an example of a simple Kanban tracking board. This is something that's actually used out in a plant, and they have these little magnetic tokens, and they have these zones. So there's a there's a yellow zone, there's a red zone, and there's a white zone. And the finished materials are here in the yellow zone. And as people come by and take finished materials, they move these tokens to the white zone. Well, at some point, they run out of white spaces, and they start getting into the red zone. And the operator actually uses this every day to determine what he's going to make. So obviously here, for this part, 1, 2, 3, 4, 5, 6, they have enough. They don't have anything in the red zone. They don't need to make any more of these. But you can see this part, we've got tokens that are in the red zone, which means they need to make some more. So as they make them, they would basically be taking these tokens from the red zone and moving them into the yellow zone. As you can imagine, this is a very simple way for you to adjust how you want to prioritize and how much inventory you want to have of different materials. like this one, there aren't a lot in the, it doesn't take many before you have to make more of these because they have much smaller of a white zone. It's just a manual way of visually showing anybody who walks up, what should I be working on. This is an example of a operator instruction sheet. I find more and more that the more you can take photos and put them into an operator instruction sheet, the easier it is for people to understand it. They say a picture's worth 1,000 words. This is an example. This is for Beery Cheese. We were doing a best practice Kaizen with them, and one of the things that they wanted to do is standardize the way we basically do changeovers, which included this blowing out of this air hose. So we took a picture of somebody actually blowing out this air hose for the slicer adjustment. They're actually slicing cheese here. Cheese is coming out and it's being sliced. And so we just took a picture of it, and then we drew an arrow with instructions on it. And we actually took these photos, we laminated them, and we posted them out in the area. We also posted things like, this is how the cheese should look, this is how the cheese should not look. We posted those at stations because, sometimes people would reject cheese that maybe it was good, but they just didn't know, or they approved cheese that had been sliced but really shouldn't have approved it. Again, this is something we do quite a bit, and I think this is probably something we'll be doing for Interstate McBee as well. Here's another type of chart. This is statistical data showing types of cancer for white females between 1950 and 1969. And again, it's a way of showing geographic data that maybe helps you visually see where there might be trends. You can see clearly there's higher amounts of cancer in certain areas than others. So in conclusion, there's lots of ways you can show information. You can use graphs, photos, illustrations, charts, models. So whenever you do show information to clients or colleagues, certainly consider how it can be shown in a way that people can readily see what's going on, because it's one thing for us to do a report and show them a table, and another for them to be able to visually see it, where they can actually understand what the results are or even tell you what's going on based on what they see. Certainly using colors, line thicknesses, and other visual symbols to enhance the message of the information. That's something you want to do. There's lots of logic around how control systems should be designed. It's all around this whole idea of visual systems. Question and answer. Does anybody have any questions for me about what I just presented?
I don't. But Bill, where did you say you used this presentation at before?
I've done this for I think Cleveland State or Tri-C. I actually did it a couple times for a class, and I think I might have also done it for IIE, and maybe also for I've used it maybe 3 or 4 times at this point. It's not something I tend to give out to a specific company. It tends to be more of a general topic. So, like for a class or an organization, like a professional organization, because it's more of a general topic.
Okay.
Anybody else have any questions?
Bill, how could you use the Beery Cheese example that you showed? What form could you create to use as a marketing piece?
This here, certainly we can use this operator instruction sheets to kind of show the way you could do operator instruction sheets. We could use it for anybody. I would just be hesitant to put it in a general present. I wouldn't necessarily want to send it out in a, hold on, let me stop recording.